Mechanical energy practice. Pay very careful attention. I'm going to walk you through every single step on the front side. The back side is yours to do on your own. So, the front side. Let's learn. I'm going to emphasize some very important vital information. We're going to calculate and record the different information about the skateboarder on the ramp. At position 3, he has reached his maximum height on the ramp. We have here, at position 1, we want to know the potential, kinetic, and mechanical energy. At position 2, the potential, kinetic, mechanical, and velocity. And at position 3, the potential, kinetic, mechanical, velocity, and the height. Vital information provided. We have a mass of 60 kilograms and a velocity of 8 meters per second. And at position 2, we have a height of 1 meter. Given that information, the first thing you need to do is find out which values are 0. So, at position 3, this tells us that right here, at this position, he is at rest. Well, what does that mean? If he's at rest, he's not moving. If he's not moving, what's equal to 0? His velocity. Velocity is 0 because he's not moving. Okay? But if his velocity is equal to 0, which type of energy is also 0? Well, kinetic energy is the energy of movement. If he's not moving, his kinetic energy is 0. So those are some values for 0. Look at the diagram. Are there any other values that equal 0 that we can identify? Well, down here at the bottom he has a velocity of 8, so his kinetic energy is definitely not 0. Here he's still going up the ramp, so he's still moving, so his kinetic energy is 0. Up here he's at the top, here he's a meter up, here he's at the bottom. If he's at the bottom of the ramp, his height is 0. If his height is 0, what type of energy does he not have? He does not have any potential energy. His potential energy is equal to 0. All right. Well, we have identified the values for 0. Now, what can we calculate given the necessary information? Well, at position 1, we know his mass and we know his velocity. With mass and velocity, we can calculate kinetic energy. So here at position 1 down below, show your work. Kinetic energy is equal to 1/2 the mass times velocity squared. So when you put it into calculator, 0.5 multiplied by the mass of 60 multiplied by a velocity of 8 squared. Don't forget to square it. That value is 1920 joules. So that is the kinetic energy at position 1. Kinetic energy at position 1, 1920 joules. Now, you need to remember mechanical energy is equal to the kinetic energy plus the potential energy. So, if I know my potential and I know my kinetic, I just add them up to get my mechanical. 0 plus 1920 is 1920. 1920 joules of mechanical energy. Now, another vital, key, detail, essential concept for you to absorb from the notes on mechanical energy. If the mechanical energy at position 1 is 1920, then my mechanical energy at positions 2 and at position 3 are all 1920 joules. That number does not change in this system. 1920 joules. So now I have all my values for position 1. Let's go on to position 2. So position 2, I know my mechanical energy is 1920 joules. Now, the mass at position 1 was 60 kilograms. Is his mass still going to be 60 kilograms at position 2? Yes, it is. His mass is still 60 kilograms. if his velocity was 8 meters per second at position 1, is his velocity still going to be 8 meters per second at position 2? No, because he's going up the ramp. As he goes up the ramp, he's going to go slower and slower and slower and slower and slower, and there he's going to stop. So he cannot be going the same velocity, but the mass is the same. Information I have, the height and the mass. So, at position 2, what can I calculate for? I can calculate the potential energy. Potential energy is mass times gravity times height. For this worksheet, value for gravity, round it to 10. All right, meters per second squared. It's usually 9.8. We're going to round it to 10 to make the math easier. Mass of 60 multiplied by a gravity of 10 meters per second squared multiplied by a height of 1 meter. 60 times 10 is 600 times 1 is 600. 600 potential energy, 600 joules of potential energy at position 2. So position 2, potential energy is 600 joules. Now we have two pieces of information at position 2, potential energy and kinetic energy. With that information, what more can I solve for? Well, the mechanical energy is equal to the kinetic energy plus the potential energy. Rearrange that to solve for kinetic energy. My kinetic energy is going to be equal to my mechanical energy minus the potential energy. Mechanical energy of 1920 minus the potential of 600 gives us a kinetic of 1,320 joules. So my kinetic energy at position 2, 1,320 joules. Now I have potential, kinetic, and mechanical energy. I know the height, I have the mass, I want to know the velocity. Now this is where you need your notes on potential and kinetic energy, because there I showed you the algebra to rearranging these formulas. Okay? Velocity is equal to the square root of 2 times the kinetic energy divided by the mass. That you should get from your journal. Plug those values in. 2 multiplied by 1,320 and divided by the mass of 60. Punch that into the calculator. To get that in the calculator, okay, you need to know how to square. So, on these calculators, you hit the second button, and then right here, the x squared. Above that's the square root. So there's your square root. So we want to do the square root of 2 times the kinetic energy of 1,320. Oops. 1,320 divided by 60. Close that parentheses. Calculator says 6.6. 6.63324989581. We just want 2. 2 is good enough. 6.6. All right, that was the velocity at position 2. So position 2 velocity 6.6 units of measure are meters per second. So we have now finished position 2. Let's go on to position 3. Position 3. I know the velocity, the mechanical energy, and the kinetic energy. What else can I calculate? Well, I want potential and I want height. Given this information, mechanical and kinetic, I can solve for the potential. These two numbers added together gives me 1920. So 1920 minus 0 gives me a potential energy of 1920. 1,920 joules of potential energy at position 3. We have all of our energy values. We know the velocity is 0. Now we want the height. This is again one of those formulas you get from your journal. I took the potential energy formula for mass, gravity, and height, and I rearranged it to solve for the height, because height's the question. When you rearrange it, it's the potential energy divided by mass times gravity. Make sure, emphasize the parentheses around the mass and gravity. You need to multiply those before you divide. Plugging in our numbers, potential energy at position 3 is 1920, 1,920. And I'm divide that by the mass of 60 multiplied by gravity of 10. Okay? 60 times 10 is 600. 1920 divided by 600 in your calculator, and you get 3.2. Okay? So, if you want to see that, 1920 divided by 60 times 10, parentheses around that 60 and 10, 3.2. So height at position 3, 3.2, height measured in meters. That's around 9.5 feet tall. Okay? So that's the front side of this worksheet. This is an introduction how to do it all, how to do these concepts. Now you get to apply that learning to the back side. I'm going to emphasize for you specific information that is very important. Okay? You need to know here that the ball is at rest at position 1. Well, right here is position 1. Here is position 2, position 3, and position 4. The mass of the ball is 50 kilograms. At position 1, the height is 4 meters. At position 2, the height is 3 meters. At position 3, no extra data is given, but if you notice, there is no measurement for height there. And at position 4, the velocity is 6 meters per second, but the height is unknown. The first thing you need to do in this problem is to identify any values equal to 0. Okay? Find values that are equal to 0. That's what you want to do first. Once you've found those values and you've recorded those values, then it'll be much easier to figure out the other calculations. One typing error right here. This is supposed to be an H rather than a V on the answers for 4. Okay? And one last time I'm going to emphasize, remember, whatever value you get for the mechanical energy, regardless of what position it is, it's the same value for all 4 positions. At any position, that mechanical energy is going to be the same number. Okay? So, identify those values for 0. Once you've done that, work through the rest of the problem. Using your formulas that are provided for you, might be helpful to know that velocity is equal to 2 times the kinetic energy divided by the mass, the square root of that. Okay? That's going to be a helpful formula for you. Okay? Remember, potential energy is mass times gravity times height, and kinetic energy is 1/2 mass velocity squared. If you can do this worksheet all by yourself, you are ready to take